Welcome back to Year 9 Chemistry. This is Week 4, Session 3, From Electron Configuration to Group and Period. Here is a secret. The periodic table is not a random chart to memorize. It is a map of electron arrangements. Today you learned the two rules that connect any configuration to an exact address on the table and back again. Let's decode the map. Your 4 goals. First, link the number of occupied shells to the period number. Second, link outer electrons to the group number for groups 1 to 7. Third, predict configurations from a position on the table. And fourth, explain why group 0 elements are so stable. The two position rules. Rule 1. The period number equals the number of occupied electron shells. Rule 2. For groups 1 to 7, the group number equals the number of outer shell electrons. In group 0, those elements have full outer shells. Helium is full with 2. Neon and argon are full with 8. 2 rules and 1 special case. That is the whole map. Apply the rules. Sodium, 2, 8, 1. 3 occupied shells, so period 3. 1 outer electron, so group 1. Sulfur, 2, 8, 6. 3 shells, period 3. 6 outer electrons, group 6. And argon, 2, 8, 8. Period 3 again, but its outer shell is full, so it belongs to group 0. Same period, 3 very different personalities. Now run it backwards, from position to configuration. An element sits in group 2, period 3. Period 3 means 3 occupied shells. Group 2 means 2 outer electrons. So the configuration must be 2, 8, 2. Magnesium. Group 7, period 2. 2 shells, 7 outer electrons. 2, 7. Fluorine. And a group 1 element in period 4. 4 shells, 1 outer electron. 2, 8, 8, 1. Potassium. The table and the configurations are the same information written 2 ways. Why do elements in the same group behave alike? Because chemical reactions involve the outer electrons. Elements in one group have the same number of outer shell electrons, so they form similar ions and react in similar ways. Note what the reason is not. It is not about having the same number of shells. It is not neutron numbers, and it is not atomic mass. It is the outer electrons, every time. And group 0? Helium, neon, and argon already have full outer shells. There is no space to gain electrons easily, and no loosely held outer electron to lose. That is why they are so unreactive. So if an exam asks which configuration is a group 0 element, look for the full shell, 2, 8, 8 argon, not 2, 8, 1, not 2, 7. The full house wins. One last thought about why this matters. This explanation is more powerful than memorizing lists because it predicts. Give me any of the first 20 elements, and the configuration tells you its group, its period, and roughly how it will behave. You have never met rubidium, but if I tell you it is in group 1, you already know a great deal about it. That is the power of a good model. Quick check. Question 1. An element has configuration 283, group and period. Pause and answer. 3 outer electrons, group 3, 3 shells, period 3. Question 2. An atom is 286. Where is it? Group 6, period 3. Your recap. Period counts occupied shells. Group counts outer electrons for groups 1 to 7. Group 0 means a full outer shell. And same group means same outer electrons, which means similar chemistry. Next week, isotopes and why one element can have different masses. For the full course, with practice questions and the final exam, visit www.selectivelytoexam.com. See you there!